Okay, everybody, recap the lesson today. We're talking really about exponential functions at this point in time. So there's two ways to write exponential functions. One is in this form, y equals a times 1 plus or minus r to the x, okay? Plus if it's growth, minus if it's decay, and this is the beginning amount, okay? So we graphed y equals 4 times 1.12 to the x power, and it looked like this. It looks like growth. We know it's growth because it's plus your rate, and your rate is 0.12, which is 12%. The y-intercept is where it begins. It begins at the point 0.04. We know that it will never reach 0 because that's exponential growth, like half of a half of a half. So we have a horizontal asymptote right here to show its boundary, so it never does touch 0. So that means our domain, of course, it's all real numbers because it's forever wide, and you can plug in any x value you want. Come on in, Reese, I'm recording your lesson. And we know the range, since it never touches the y-axis, and we know it can never be 0, the range is just y is greater than 0. Yes, Reese, while I'm recording. Everybody say hi to Reese.
Hi.
Yes.
I'm not going to be at church today.
How come?
I'm not feeling good. I have a doctor's appointment tomorrow.
Okay, go home and get well.
Okay. Thank you.
Okay.
Bye.
Pretty soon I'll start leaving kids home. They won't go to meets. They got to come to practice. But okay, if you're sick, you're sick, okay?
Yeah.
All right. Second example really has to do with decay. We start with 100, so I have an asymptote, or I have a y-intercept at 0, 100. And it's decay. You have 80% of something, which really means you lost 20%, okay? So it's decay. We put it on the graphics calculator. It looks like this. We know the decay rate is 20% because we can rewrite it as 1 minus 0.2, or we know that if it's 80%, we lost 20, okay? Again, we have our asymptote. Domain and range are exactly the same. X is greater than all real numbers. Y is greater than 0. Growth, decay. Then we took a problem. Okay, let's actually apply a problem. We have something that's going to decay at a rate of 15%. 15% is 0.15, so I'm going to put 1 minus 0.15 because that's our decay rate. We start with 40 grams. I plugged 6 into my exponent. I used my calculator, and I got about 15 grams remaining, okay? On the next page, we went through exponential rules. So first of all, if you have a negative exponent, we always have to move it, okay? We talked about, think about fraction, move it. So x to the negative n is 1 over x to the positive n. We have exponents that have negative exponents. We brought this one down as x to the positive n, this one up y to the positive m. So if they're negative exponents, we just move them. Okay, as a fraction, we just flip it. The y went up and the x went down, okay? So let me take a look at some problems. First problem, I moved all of my negative exponents. Brought that one down. X to the negative 5 I brought down. Y to the negative 2 actually brought up. And then y to the 4th actually brought up. Then I simplified. That's 9. 3 squared is 9 times 5 is 45. And then I was able to simplify. Y6, and then I was able to cancel some x's. My grand answer is y to the 6 over 45 x cubed z cubed, okay? B is actually not too bad. I brought this one down because it's negative exponent, so I brought it down. Anything negative has to move. And then I applied this fraction rule, so I flipped the fraction, and then I squared it. So I got A6, B8, so I multiplied exponents, okay? C, the first thing I did is I moved the x to the negative 3 down. And then because it has a negative exponent, I flipped it. I don't really need the 1 power, so I just wind up with x cubed over y4, okay, or 4y. D should be written like this. The typewriter, computer doesn't really type the way I want it to, but it really should look like this. So the first thing we did is we flipped them both because of the negative exponents. Then I brought through the exponent a squared b4, brought through the exponent b cubed a6, and then I cross simplified. It's faster. 2 of these cancel 2 of these, a4. 3 of these cancel 3 of these, b1. Now you have to have a fraction, so it's 1 over, okay? E, I simply brought this term up, made it a positive 3, and then I multiplied. Add exponents, x8, add exponents, x1, okay? All right, now here's the hard one, but we can do it, okay? So a to the negative 1 plus b to the negative 1 all to the negative 1. What do you do? Because of the plus sign, you can't really just bring it through. It's kind of a pain. So 1 over a, 1 over b. But now to add fractions, I need a common denominator. Multiply this by b over b. Over a, I have a common denominator of ab. So I have a b plus a. So now with the negative 1, I flipped it. The ab goes up above, and b plus a or a plus b. Okay? Same answer. And there is your homework. So, if you have any questions, talk to me, and I'll help you out. Okay?